Hey y'all, happy Sunday and welcome to this week's live Q&A session. This is the portion of the show where we allow YouTube to send out notifications that we're going live. If you're watching this live Q&A on replay, please scrub ahead until this graphic disappears and the actual show begins. If you're watching live and you have any comments or questions, please go ahead and put them in the live chat. But for now, grab a beverage, sit back, and relax while the countdown timer does its thing. Then we'll get started. Hey y'all, happy Sunday. Oh man, it has been a week, and here's hoping everything gets a little bit better, a little bit easier on all of us. I know you folks back east have been having some seriously rough weather. Folks in the Midwest are about drowned out. And let's hope it kind of calms down a little bit and folks can get back to something a little bit closer to normal. Hang in there, baby. It's coming. All right. Today, I wanted to kind of do a little bit of a deeper dive into two-sided machining. Last Monday on my members only live stream, we got into two-sided machining a little bit, and more questions came up than we had answers. So basically, what I decided to do is go ahead and come over here onto the public side, and we're going to talk about two-sided machining. So if you have any questions about two-sided machining at all, feel free to put them over here in the chat, and we'll get to them in due course. But before I do anything else, I want to give a shout out to my friend Steve over at Harneal Media, who is the sponsor of Mark Lindsay CNC. Now, if you're even toying with the idea of a website, Steve is the man that I would recommend. Head over to harnealmedia.com. There's a link in every video on this channel for a reason. And hit that contact us button and reach out to Steve. Let him know kind of what you have in mind. If you want to set up an e-commerce site, he's got you covered. You want to set up a web store to put your products or services out there to the public, he's got you covered. If you want to develop merch, t-shirts, baseball caps, coffee mugs, things of that nature, he's got you covered. He can hook you up with a print-on-demand company that will take care of all the inventory, collecting tax, shipping, all of that stuff. So reach out to Harneal Media. Link, as I said, in the description of every video on this channel. It's 100% personalized service. Whenever you're in contact with Harneal Media, you're in contact with Steve, not some nameless, faceless person in some call center outside the country that you'll never talk to again. He gives you performance, not excuses. So thank you, Steve, for everything you do. I greatly, greatly appreciate it. Now, when it comes to two-sided machining, there are a few misconceptions, and what I wanted to try to do was try to maybe clarify a few of these misconceptions and some of these sources of confusion. But I'm going to give you fair warning. Two-sided machining is highly, highly addictive. Once you have that light bulb moment, you get that, aha, that's how you do it. You're going to come up with excuses to do two-sided projects. It's that addictive. I'm serious. Things that don't need to be two-sided, I'll do two-sided now. So just fair warning. It's a lot of fun. It's very, very cool. And when you get that material flipped over, fastened down, and get cut out, and take the project off the table, and both sides line up the way they're supposed to, and everything is perfect. If you're anything like me, you turn into a 5-year-old again, and you start dancing and skipping around the shop. It's that fun. So let me go ahead and bring up a sample project that I did in a video several years back. And this video was, it was well received. And folks reached out to me about this project. It's so simple, but it's one of those things where you just go, oh, why didn't I think of that? And that was this project of a set of basically covers for the lid of a home canning jar, mason, ball, whatever type of a canning jar. And let me bring up, I know I have a picture of them here. That is the finished project when it was all said and done. My wife is a tea aficionado, and so I made little lids for her tea to put her different favorite teas, and made her a little walnut shelf to put them up there. Then I had my buddy Billy Burt turn her a little coffee scoop for measuring out her tea out of the same material that these jar lids were made out of. So she's got her a nice little setup there. Now, yeah, yeah, Bob Heltebrottle notices. Yeah, I do not baby my spoil board. Never have, never will. I just surface it and drive on. Um, the the thing is, this was such a simple little project. People who watched the video were reaching out to me. How much for a set of 4 of these? That's a great idea. How much for a set of 6 of these? And I have to say, I just showed you how to make one. Why would you want to buy them from me? So, but they were received very, very well. And it's as simple as can be. When you're creating a two-sided project, what you have to wrap your head around, and this is the most important part of a two-sided project, is in your material setup. We'll set it up for double-sided. I got the length and width and thickness of my material here, my Z0 position, my XY datum position, and the crucial aspect of this is which direction you're going to flip the material. You have 2 choices down here. You can flip your material side to side horizontally, or you can flip it vertically. Just remember which direction you set, and when you get outside on your machine, flip it in that direction. There's another crucial aspect to this, and I'll get into that in just a minute. But that's the main part that kind of comes back to bite people. Now, 8th Center says, would be nice to be able to do threaded jam, pickle, beetroot type jars. You most certainly can. You most certainly can. That would get into thread milling, and that's outside of the scope of this video, but I really don't know where you're at. But here in the States, we have a lot of home canning where people will can fruits and vegetables, and they sell these jars that are made specifically for that. And in fact, I have one right here. It's a little bit different color, but I also use them a lot for just mixing up, say, shellac. I'll put the shellac flakes in here and then add the alcohol and dissolve it all down and everything. I use these jars for a lot. And outside of the States, I don't know how popular. Well, the talk on threading the other day was over my head. Yeah, mine too. I haven't done it yet, but I'm going to. familiar with mason jars, but they aren't as popular in the UK. You might have to order them online. They're not super expensive, at least here in the States. I can't comment on the UK, but they have the jar, obviously, and then the lid is a two-part affair. It's a metal ring that you can reuse over and over again. And then this lid, it comes with the jars. I bought, it's 12 jars I got for about, I don't know, $10, $15, something like that. And these are not reusable. You use them to home can. And when this is, you've opened up the jar, you can reseal the jar with it to put in the fridge, but you cannot recan with the same lid. You throw this out, and they sell these lids separately in little packs of however much. But what we're doing is we're on this two-sided project, we're going to epoxy this ring into this wooden cover. And that's what this whole project was. Now, Bob says they also make a one-piece lid. I've not come across them. Then again, I haven't really looked for them. So, I just haven't seen them. But getting back into the project, once you have this set, drill it into your brain. Just drill it into your brain that this is the way you're going to flip your material. So I'm going to cancel this because I don't want to have to recalculate my tool paths. Now, I kind of took this a little step over, a little step above, and I added 3D dishes to the top of these jar lids. Just a little, very shallow dish. And, well, hey, this is what I love about having quality control right here handy, because my wife pulled one of these lids off, and here is the finished project. Let me take this down. This is one of those lids that you saw in the photo. And all we did was we hollowed out the back side. And this is one of these replaceable lids that can come right out. And it's got a very shallow dish in the front. And I V-carved the type of tea that she uses in this jar. And oh boy, does it smell like tea. She's had these for a couple of years. But all I did was, again, I epoxied this ring into the back of that. And they're all pretty much universal size, no matter which manufacturer you get them from. And there you go. So it's a real simple, real easy project, and it's very, very well received. So let's see here. We've got a couple of questions coming up, and I will get into them. I honestly, I will. All right. So I put a very shallow dish in the lid tops, and I did all of this on V-Carve Pro. I did not have a spire when I made these. So this is exactly the same in V-Carve Pro. So back over here to the 2D view. Now, version 12, they made a few changes up here in the in this area. So now here is the button to flip between the top and bottom sides. Let me mark that question. So my rulers are gray. That tells me that I am on the top side. If I click on this button here and go to the bottom, my rulers turn orange. that tells me that I'm on the bottom side. Okay? Something to pay attention to. And this is one of the things that confuses people for some reason. And I've got an example set up over on the CNC. I'll switch cameras in a minute. But if you look at these circles here and here, again, we're on the bottom. Let's look at the top. Now they're in this position over here. Remember, I am flipping this piece of material horizontally, end for end. I'm not flipping it vertically. So when I draw these circles for my locating dowels, it will be the first tool path I run before I do any of these others out here. I'll draw these circles, and you'll notice they're in an asymmetric shape. So I cannot confuse them. The dowel hole on top will stay on top, and the down hole on the bottom will stay on the bottom. I can't confuse them. I have since changed this slightly in that now I use 3 dowel holes, where I used to use 2. 3 dowel holes just kind of helps guarantee that you cannot flip this wrong, because it physically will not fit if those alignment holes don't match up. You physically cannot put it back down. So the first thing I'll do is I will draw these alignment holes. Then immediately, I'll just demonstrate on this one down here. Select it, then right click, then copy to the other side. When you do that, select them both or all 3, copy to other side. Now I'll flip over to the bottom, and now they're on the bottom. This is the part that confuses people. You're thinking, wait a minute, now it's over here. On the other side, it was over there. That's not going to line up. Now is when I need to switch cameras and come over here and demonstrate on the CNC machine. So let me switch over cameras, come over to here, and I'll step over. Now I will also use an auxiliary spoil board whenever I do a 2-sided cut. The reason for that is I'm going to drill alignment holes in my material on the top side. And then when I take this off and go to flip the material, I need to drill the corresponding alignment holes here in my spoil board. Well, rather than have a bunch of random holes all over the spoil board, what I'll do is mount this accessory spoil board on my table, and I do that with my alignment dowels. I've got these precision ground steel dowels. Put 2 over in the corners, 1 up here somewhere, 1 down here somewhere. Then I will fit that auxiliary spoil board and screw it down. Then I can take up these steel dowels so I'm not in danger of running into one. Now I can bring my material over. And I have decided that this is my top surface and that this is the bottom surface. And I'll bring it down, and I can line it up with the bottom edge of this auxiliary spoil board. And this, in this case, this piece is Baltic birch plywood. I have used MDF. I've used other types of plywood. Doesn't have to be anything special. just something that is bigger than your piece of material. Now I will attach my piece of work material to this auxiliary spoil board. I'll grab my touch plate and I'll set my XY0 to the bottom left corner. This is the other crucial aspect with double-sided machining. Once I have set my XY0 to the bottom left corner, I will not change it for the rest of the project. Set it once, I'll cut one side, take it loose, flip it over, line it up with my alignment holes, fasten it down, and then do the other side. I will not reset my XY0 after I have flipped it. Now, there's some confusion. We were talking about the alignment holes look like they're not going to match up. I believe you can see I have an X drawn here, and I've transferred a line onto the edge to tell me where that X is. Remember, when we flip this material over, we're going horizontally side to side, end for end. And look at where that line on the edge of my material is now. It has moved that circled X from here to there. Any other alignment holes will also be shifted over here. So, again, I'll mount my spoil board, take up these steel dowels, get this aligned with my auxiliary spoil board, screw it down, mount it down, set my XY0, then drill my alignment dowel holes. That'll be my first G-code that I run. Then I'll run the rest of the project. When that's completely finished, I'll take this loose, put in the G-code for my alignment dowel holes that go in the spoil board, set my Z0 to the surface of this spoil board, and drill those alignment dowel holes. I use 1/4 inch dowels. These are just 1 inch dowels that you can get in packages, or just buy a 3-foot length of hardwood dowel for less than $1 and cut them into, I cut them into about 7/8 of an inch, not quite an inch long. When you have these holes, I'll put my dowels in those holes, bring my material back, flip it end for end like this, and then, to be honest, spend a few minutes getting this puppy lined up before it drops down. And it will drop down, it will seat. I'll fasten it again, then run all of my bottom G-code. Do not reset your XY0 after this is fastened down. The G-code is being calculated based on where that XY0 was set when this was the bottom left corner. The software knows what to do. It knows to make any adjustments. Do not reset your XY0 when you go to cut the other side. And then when that's finished, you can take it off, cut any tabs should you need to, if you put any tabs in it, and then it becomes just a standard woodworking project. Once you have done your first project, your first double-sided project, and you get that that light bulb moment, and it works, it becomes an addiction. I'm telling you. Now, this is a comment I get all the time. I normally do 4 holes evenly on the corners on the first side into the spoil board. Then you can start your machining file. When you flip it, it works perfect every time. If it works for you, continue to do so. But if there is a way you can put that on wrong, and doing 4 even holes all the way around, you can put that on upside down. You can put it on backwards. I don't mess with it. I don't mess with it. By doing an odd number of alignment holes, I can't put it on wrong. It's Murphy proof. And this, Michael, I'm not saying anything against you. I'm saying something against me. If there is a way I can mess it up, I'll find it. So to alleviate any issues, I could cut the top and leave my wife come in, flip it over to do the bottom. She doesn't have to know what I'm doing. She can flip that thing over, get it mounted by aligning those 3 dowel holes and fasten it down and cut the second side. Now, it hasn't come to that. She's not interested in anything out here. But what I'm getting at is by making 3 asymmetrical holes, you can't get it wrong. You can't get it wrong. Now, yes, you can use more alignment holes if you want, but it's not really necessary. I used to use 2 all the time. But again, if there's a way I can mess it up, I'll find it. I found it. So now I use 3. And it won't go on any other way. So, and Russell has it right here. You're 100. I agree with you 100%. As many peg holes as you like, but not symmetrical. So you can't flip it the wrong way. Well, you can flip it the wrong way, but it's not going to fit. So, okay, so let's get into the tool paths that I used to make these, and then I'll get into your questions here, okay? I'm going to go back over to the top because the order of operations is important here, okay? The cutout, profile cutout tool path is always the last tool path I calculate and always the last tool path I run. Because again, if I can find a way to mess it up, I'll find it. There's only been a couple of times I've done it, but do the profile cutout and then discover I have 1 or 2 more machining operations to do. Well, if it's in something that is large enough, I can kind of recover from that. But when you're talking about 4 individual pieces like this, it becomes a little bit more difficult, especially if you've machined away a lot of a surface, like on these 4 lids. Because remember, I've got a dish here, and then on the bottom, I've hollowed out this entire area. So the profile cutout is always the last tool path I'll run, and I save it as its own tool path, so I can't mess it up. So we're looking at the top here, and it's telling us we're looking at the top. The first G-code I run with a 1/4 inch end mill, 1/4 inch upcut end mill, is these dowel holes. These will be drilled in the surface of the material. Okay. So I'll go ahead and I'll preview those. And that's just, in this case, 2 holes, and boom, boom. There they are. I now have my dowel holes in the surface of my material. These are drilled a 1/2 inch deep. And make sure when you're drilling with a drilling tool path, use an upcut bit. Don't use a downcut bit. Then I have my 3D finishing tool paths. And that is simply cutting the dish in the top of this lid. And we'll preview that. Oh, no, 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 no. We're not going to do that. There's no way to speed this up. I'll let it finish this one. Then we'll just, there, let's finish that one. Then I'll V-carve the text into that dish. And when we get to the V-carve toolpath, if we look down here, it's just regular text in a V-carve toolpath. I have check marked project the toolpath onto the 3D model. So it's going to carve that text into this dish. Close that. I don't need to recalculate it. And I'll go ahead and preview that. It's going to look funky on these where the dish hasn't carved, but that's okay. And you can look at the difference because what it has done is it has carved this assuming that the dish has been cut. Well, you can see the difference. That's what it would look like if I hadn't cut the dish yet. This is what it looks like after the dish is cut. So that's fine. So then the next one, I put a slight chamfer using the same V-bit that I used for the V-carving. I put a slight chamfer on the top of this lid. And we'll carve that. And there we go. That's the top. The top is finished. So now we'll flip over and we'll do the bottom side. On the bottom side, the tool paths are, come along, there we go. I'll do a profile that's about a 1/16 of an inch deep. Let me take this down real quick. If we look at these particular jar lids, this little rim right here is about a 1/16 of an inch tall. If I just cut out the pocket to hold this rim, this is going to keep that jar lid protruding out the top of the wood. Well, I wanted it to sit flush. So I cut a very shallow groove for that rolled edge to sit in. And it's about a 1/16 of an inch deep. So we'll go ahead and we'll preview that tool path. And it was just a single pass with the same 1/4 inch bit that I am going to cut out the pocket with. Something I forgot to do. I forgot to, yeah, I'm not sharing. So that's not a big deal. The very first thing I will do on the back side is take my material off, set it aside. I will set my Z0 to the top of the spoil board, my auxiliary spoil board. I'll set my Z0 there. Then this tool path, the dowel holes cut in table, that's what I'm going to use to cut my alignment holes in the spoil board. So I'll set the Z0 to the spoil board, then I'll cut these. We'll go ahead and preview it. And because I have drilled the alignment holes on the other side, on the top, this may show up as being cut all the way through. Okay, it's not. That's fine. All right. These holes are not cut in the material. They're cut in the spoil board. Now I'll reset my preview because they won't be there. They'll be in the spoil board. So back to that little profile cut for the rim of the lid. I'll preview those, and it's just a simple profile. After I have my alignment holes cut in my spoil board, I'll line my material up and fasten it down. Then I'll cut this toolpath that I just cut. I'll set my Z0 to the surface of my material, then cut this toolpath. Do not reset the X and Y0. Then I'll pocket out for this whole lid, and that shouldn't take too long. But you see how deep that's cutting and how tiny that little recess for the rim of that lid is. Now this is cutting 5/8 of an inch deep in metric. Let me see what that is. 0.65. That's about not quite 16 millimeters deep is how deep I'm cutting these pockets. 15.875. So you might as well say 16 millimeters. Then it'll finish pocketing those out. Come on, you can do it. You can do it. Faster, faster. All right, there we go. And now we've got a straight on view. Now comes my profile cutout. Now up here, someone was asking, okay, Javier de Jesus, if you use tabs and you want to do an edge chamfer or round over, how do you do that without cutting tabs? It's all on where you place the tab and how thick you make the tab. Now, for instance, when I did the chamfer on the top side, that little chamfer right there, I had to make sure my tab, that this chamfer wasn't going to cut through the tab. And I just did this basically knowing that my bottom side, the profile cutout was going to be the last side that I cut. That was going to be the last G-code that I cut. And when I did my profile toolpath, I add tabs and I made them a 1/2 inch long and 3/8 of an inch thick. Let's see how much that is metric. 0.375. That's about 10 millimeters. So I made those tabs about 10 millimeters thick and about 12 millimeters long. Okay. And we can see I put them on the top and bottom because I knew I would be cutting in between these. So on this one, because it was so close to the edge, I put my tabs over here. So this one got 3 tabs. The rest of them got 2. And by making them that long and that thick, that chamfer on the top did not affect those tabs. Okay. So let me close this. I'm not going to recalculate it. I don't need to recalculate it. Go back over to the 3D view and we'll preview this one. And here's hoping with that tool animation gone. It won't take too awful long. But you can see these are some pretty large tabs. And I did that to make certain that when I had cut that chamfer over here on the top side, that chamfer did not cut through these tabs. Now, what I can do to kind of preview this a little bit better is I'll go ahead and preview all sides, and we'll get to a couple of other questions while we're letting this preview. Let's see here. Eight Center is asking, the walls look very thin. What, like a quarter of an inch? You know, right about that. Let me check it here real quick. And about 3/16 of an inch thick. But again, we're not building a bridge. 3/16 of an inch is, let me get this figured out in metric. 3/6 of 1875.1875. So yeah, the wall thickness is between 4.5 and 5 millimeters, closer to 4.5 millimeters thick. But again, we're not building a bridge. It doesn't have to be super strong. The wall thickness doesn't have to be huge. It could be thinner than this, and it would do just fine. Because remember, we're just talking about a jar lid. It's not holding up any weight. It's not under a lot of pressure. It's just a very simple little, more or less a dish that we're epoxying this ring into. So, all right, now I can get a little bit better look here. We can see I've got my tabs, and when I do that chamfer, it does cut into the tab slightly right there, but not enough to affect the integrity of that tab. You see how thick that tab is underneath that chamfer? So it does work out very, very well. And this was long before the chamfer toolpath came along. This was just simply using a profile. And let's get into it here. I'll have to go over to the top of the sheet. Come on, flip over. And back over to the top. And the profile chamfer is a profile toolpath with a cut depth of 0.1, which is how many millimeters? 0.1. It's about 2.5 millimeters deep. And I'm using a 90-degree V-bit, cutting on the vector. And that is the same vector that will be used for the profile cutout. Again, once I made that vector, I copied to the other side. So it's the same vector that's used for the profile cutout. Now, I'm not going to recalculate. I don't need to. Close. But that's a real quick and dirty way to put a chamfer on the edge. They just use the same vector that you would use for the profile cutout with a V-bit of your choice, and set the cut depth for however deep you want that chamfer to be. And as you can see on this, it's not very deep at all. And that was done with a 90-degree V-bit. But it adds a little bit of style, a little bit of flair. It also helps to avoid chip out. When you the profile cutout's done when this is upside down. I did use a downcut bit because I wanted a nice surface. That chamfer, when that bit came down to cut through that last level, any chip out is going to be on the waste material only. It's not going to be on this because that's already been chamfered away. There's nothing there to chip out. So, Steve also makes up a good point about the strength of this wall thickness. It's also epoxied to a steel ring. So, and all I did when I epoxied it, I wish I could get that lid out of there. Well, anyway, all I did when I epoxied it, so I put a little bit of epoxy on the inside around the edge here and just pushed it in without this lid in it. That was dropped in after the fact. So, very simple project, very easy project. And the important things to remember are which direction you're going to flip your material. And it doesn't matter which way you go, as long as you flip it in the same direction that you told the software you were going to use here in Job Setup. But I'm here to tell you, it's extremely addictive. It's extremely addictive. I later went on to do another double-sided project, and that was for a little shelf for my wife. Now, you might think, what has this got to do with two-sided? These are shelf corbels. And they were to put a shelf up on top and then a 1-inch diameter wooden dowel down here. She could put things along the top of the shelf and then put a 1-inch dowel going from this one to this one and hang yarn off of. The reason it was two-sided was because this iris pattern was on both sides. So, if you look at the pattern, you've got a big iris over here, or excuse me, not iris, lily. You've got a big lily facing off to the right, but if I flip over here, it's facing to the left. That gives you the exact same look on both sides. So it doesn't look backwards when you walk over to the other side of that shelf. So, Steve said, if you drilled a pinhole in one of the letters, you could use a pin to push out the lid. Yeah, or I could just take a piece of tape, flip it in a circle, sticky side out, and stick it to it and pull it out. But I think, I can't confirm this, but I think that's what she did. I think she put a little bit of tape in there and then pushed this in so it wouldn't keep falling out. I wouldn't put it past her. She's watching the chat, so maybe she'll tell me. Okay, let's get back. We have a couple of more. Let's see here. A.L. Peleg says, how many G codes do you have for drilling the holes? Which side of the model do you get each G code? And how deep does each of them go? Okay, the depth is a 1/2 inch. I don't need to go much further than that. I don't want to drill all the way through that auxiliary spoil board because I want to be able to reuse it. How many G codes do you have? 2, 1 for each side. Which side of the model do you get each code? The G codes are kept separate. The G codes for the top are kept on the top. The G codes for the bottom are kept on the bottom. And in fact, when I didn't bring in the folder, the G code folders, because as I said, I don't save G code. When I do save, okay, there she is. I put the lid in to keep the tea fresh. she used that blue poster tack to stick the lid inside so it quit falling down. I see it now. Okay, blue tack. Let's see, let me go back to the jar lid file here. There we go. You have, when I save the G code, I create two folders on my flash drive. One is for the top and one is for the bottom. Again, if I can find a way to screw it up, I'll find it. So I don't take any chances. I make one folder for the top of the project and another folder for the bottom. This being the top, all of this G code will get saved in that folder for the top. Then when I save the G code, that will go into that folder for the bottom. That way I cannot make a mistake. You'll have two pieces of G code for the dowel holes. And again, this is why I tend to make I put G code into separate files. Think of it this way: when it's time to do the bottom, I'm going to set my Z0 for these dowel holes to be cut into the table. I'm going to set that to that spoil board. That's where my Z0 is going to be. When I start the G code, it's going to drill those alignment holes, then come back and stop. I will then, using the same bit, but a separate piece of G code, I'll set my Z0 to the material surface after I have it mounted down. Set my Z0 here. Then I'll cut out that profile for the rim of the lid, that little rolled edge. And on the same piece of G code, do the pocket that'll hold the depth of the ring. Then come along and do the profile cutout last. All of that is saved to one piece of G code. You just have to make sure that you have profile cutout last. That's it. So, Travis Scott says, I put a 1/4 inch by 3/8 deep index hole in the spoil board, 1/4 inch deep hole in the part, then use 1/4 inch oak dowels that are 1/2 to 9/16 long. Yeah, and if it works for you, great. That does work. I don't use these location dowels. I don't use them over again. And I generally don't use the same holes. In fact, what I'll do, is I will, when I've finished a project, I'll take a Sharpie, a magic marker, whatever, and I will circle those holes so I know they've been used already. So the next time I go to do a two-sided project, if it'll fit on that auxiliary spoil board, I know when I drill my alignment holes in it, it's the uncircled holes are the ones that I want to use. There was a piece of plywood around here. I don't think I have it anymore. It must have had 15 or 20 different holes in it. But when I was finished with the project, I would circle those holes with a Sharpie pen, and I knew not to use those. So the next set of alignment holes were the ones that weren't circled. So, okay, Javier, I thought I heard you say not to reset your Z. No, you will reset your Z. You will not reset your XY. You will reset your Z after every bit change. Or, for instance, on the bottom, like we're talking about right now, I will set my Z0 with that 1/4 inch upcut bit mounted in my spindle. I'll set it to the surface of that spoil board. Then I'll drill those two alignment holes. Then I mount this piece of material after getting the alignment holes figured out, got my dowels in there, and I fasten it down. I'll set my Z0 to the surface of this material and then carry on with the remaining 3 tool paths. So you do set Z, but how long does it take to reset Z0? Personally, I cut all of these 3 with a down cut bit, but I always drill my dowel holes in with an upcut bit. So there is a bit change involved here. So resetting Z0 after a bit change, that's the norm. Let's see here. STL Woodworking, Greg, how you doing? I do it that way to save me from having to set the Z an extra time. Well, I mean, if it works for you. So, oh, wait a minute. I see that was part 2. I do the same thing. I zero to the material surface. Then when I set the 0 for the holes in the spoil board, it's already set for the bottom card. Okay. So what Greg is saying is over here let's go back over here to, sometimes having 2 monitors gets confusing. What Greg is saying is that here in his job setup, he sets Z0 off the same side. I didn't do that for this project, but I see what you're saying. If you set Z0 off the same side, and this is the reason I didn't do it, Greg, was because, again, if there's a way to screw it up, I will do it. I will find it. What will happen is I will get used to, because I'm forever used to setting my Z0 to the material surface. I'll set Z0 to that auxiliary spoil board, but then it's just in my brain. It's second nature. I'll come back and I'll set my Z0 to the material surface. Then when it starts machining, I've got a mess. So I tend to just go off the material surface and not zero off the same side. But much like everything else, there are probably almost, but not quite, a bazillion ways of doing it. So when you find the way that works best for you, by all means, go for it and stick with it. Consistency is almost as important as the method, because if you get used to doing something a certain way, trying to get yourself out of that habit and into doing something else is, for me, a good way of getting in trouble. So I try to make things as easy on myself as I can. I'm not an expert. I'm just not afraid to fail in public, you know, and I do quite often. All right, let's see. We got one more question here, and I think I missed something. So let me go back. I'm going to have to scroll through the questions up here, and because I think I only got one half of the question. No, it's not looking like it. Okay. Code into the tool paths the type of flip you need to perform. Oh, okay. I think I see what you're saying now. I think what you're saying is when you title the tool path, code that into the title, flip side to side. I can see that. I can see that. Now, if you have a Spire or if you have VCarve Pro, and again, this works the same way in VCarve Pro, you have something else, and that is up here in the toolpath menu, create a job sheet. So I can click create a job sheet, and I'll put it in the same folder as what I've got here. Save, and let it save. Now I'll get into that folder. And there is, with the Chrome logo, there is my job sheet. Let me open that up. Of course, it opened over here, and I've got to drag it over. This is a job sheet. And we can see here, there's the material border. Here's my material setup, and right there, material flip direction, horizontal. I am not sharing. Okay. Sorry about that. Here's my job sheet that was generated. And in material setup, job type, double-sided. Material flip direction, horizontal. Right there. So it also is telling you the size of your material, your home start position, Z0 at the top of your material, XY at the bottom left corner. You can either save this as an HTML file, which it did, and I guess I wasn't sharing, so you didn't see how I made this. But this is only in VCarve Pro and Aspire. This is not available in VCarve Desktop. Go to the Toolpaths menu, come down here to create job sheet. Click on that and enter your title, and it'll save it as an HTML file. Different people have different ways of reading HTML files. With mine, I just have the Chrome browser open it up. So that's how I read an HTML file. You can either print this out, or you can transfer this over onto your flash drive along with your toolpaths, your G-code, and you'll have it right there handy when you go to run these toolpaths. We're showing the different toolpaths and what bit it takes and estimated time it's going to take. And then each toolpath piece by piece. Now, this is for the material bottom. You can create a job sheet for the top, then again for the bottom. So let's go do that. I'm going to close this, and I'm going to get into my folder here. And okay, it already says summary bottom. All right. Now I'll flip over to the top and toolpaths, create job sheet. And it just says summary. I'm going to add top. That way I don't, again, if there's a way I can screw it up, I will. I'll find it. And now come back into that folder. I have two HTML files. This one's the top, this one's the bottom. And of course, it opened up over here. So now I have it showing which side of the project it is. Side of material, top. Material flip direction, horizontal. It gives me all of that exact same information. One for the top, one for the bottom, and goes into the toolpaths one by one, showing me which end mill I'm going to use, etc. But there is the important part right there. Which side of the material the job sheet's for, the material flip direction, right there. So again, that's available only on VCarve Pro and Aspire. It is not available on VCarve Desktop. It's just one of those things. So, are there any questions at all that I didn't get to about two-sided machining or anything else? You know, Greg says, a wise man once said experts failed the best. Well, I don't know about that. But see, I very rarely learn anything from my successes, but I almost always learn something from failures. Even if all I've learned is, oh, so that's why they don't do it that way. I think that counts. You know? Let's see. Brooks Martin says, FYI, my post processor does not include material flip direction in the G code. No, it won't. The post processor doesn't have anything to do with that. It's just telling it where to go. Um, it doesn't care what side you're cutting. That's why you have to care. So, let's see here. Are there any other questions at all? Welcome aboard, Thomas. I saw you joined us a bit late. This moment, Germany watches football. Yeah, hey, I get it. I understand. So that's going to be an issue here pretty soon, too, because American football season starts not too far away. So Russell Faraday says a professional is very good at recovering his mistakes. My grandfather was a carpenter his entire life, and he once told me that the difference between a carpenter and a craftsman is a craftsman knows how to hide his mistakes. So, I mean, we're only human, and we're dealing with a natural product. We have control over certain things. But if you sit back and kind of analyze it, it's kind of surprising just how little we actually have control over. Because, this piece of material, as an example, I glued up strips of maple. This is just a maple glue up that I glued up to use for a in-grain cutting board. This was just a bunch of scrap, and this is what was left over. And when I glued this up, it was nice and flat. I surfaced it on the CNC router before I started cutting strips. But if you look at it, it's now bent. It has now got a nice dip. It's cupped. The center being low and these two being high. Well, it sat out here in the shop for about 8 months. So no, it's not going to be flat. So what I'll have to do is I'll have to flatten it again, which means it's even going to be even thinner when I go to use this piece of maple. But, very little in our control. We're working with natural products that are going to do what they want to do, whether we wanted to do that or not. So you just have to kind of work within the confines of what you're working with. So, let's see. MJ Jensen says, would like to see your procedure, for those of you who can speak, procedure to do two sides with tiling. So would I, MJ. I've not graduated to that point yet. I've not, I'll be honest, I haven't had the need to do much tiling at all, as evidenced by how long it took me to get that tiling toolpath video shot. So no, I've not done this, but that would be intriguing. I think basically what it would come down to would be the same thing, just you would tile the top and cut each tile, then do your flip and cut each tile. So now I'm assuming, and that's easy for me to say. So let's see here. Frank Majewski says in metal trades, a machinist's best friend is a welder. Yeah. He also, that's another thing that my grandfather passed on to me. If you have a pickup truck or a welder, you will always have friends. If you have both, you're the most popular guy in town. So, alrighty. Well, it doesn't look like we have any more questions on this. So, let me ask you, what do you want to see next week? I'm going to try to have a video, but I need your input. What do you want to see next week? What topic do you want me to cover? Leave, if you're watching this on replay, leave a comment down in the comment section. Is there something that you don't really understand? Is there something you would like a deeper dive into? This is not about me. This is about you. I'm just here to show you folks that none of this is over your head. Like I say, 9 years ago, I couldn't spell CNC. Now I've built 4 of them. If I can do this, I know you can do this. Okay, my channel members are going, rotary, rotary, rotary. Okay, that's what I'm going to try to have. Don't make me come over there, Brian. I'm going to try to have a rotary video next week, and we'll see how it goes. But I'm definitely going to give it a shot. If you have any questions, comments, concerns about two-sided machining or anything else for that matter, leave me a comment. That's where I get ideas for videos. I scour the Facebook groups and check in on my emails and not troll, but go through the comment section trying to find ideas for videos. It's what you guys want to see. Get into the comments and let me know. If you're confused about something, by Godfrey, I'll put it up. We'll see what we can do about a rotary project next week. Channel members. Tomorrow we have a special guest. Mike Bernasconi is going to do a presentation on parametric projects, parametric carving, yes, using Vectric software. It not only can be done, it's done quite often. He's done quite a few projects. So he's going to do a presentation on how to cut parametric projects using VCarve Pro and Aspire. So that will be tomorrow evening at 5:30 Pacific, 8:30 Eastern. Be there or be square. If you don't know what I'm talking about, or you want some information on how to become a channel member so you can check out some of these members only live streams, click that little join button down there by the subscribe button. And what is parametric? Leo is asking. Give me a second. Click that little join button down there by the subscribe button. You're not joining anything. You're just getting information. A panel's going to pop up and a video is going to play. That'll tell you all about channel membership. Do hope you join. We have a great bunch of people. And then we'll hook you up with the super secret Facebook group and live chat that really gets busy. What is parametric, Leo says? Well, let me see what I can do here. And I know I'm not sharing just yet. Let me find it. There it is. And let's do, which one should I do? Mike I'll do this one. And that's a parametric project. That's a parametric project. Now here I am, dummy, trying to right click and twiddle it around. That's a parametric project. You've seen them. They're all over the place. Things like that right there. All right. Leo, let's help you out here. I am going to go to YouTube. Come along, mate. Then I'll go to my channel. And let's say I got to watch a video here. We'll just do this video. Doesn't matter. Stop. I don't want to hear it. Right there. Join. So click that join button right there, and a panel's going to pop up in front of this, and a video is going to play. That'll tell you how to go further with channel membership, or how to get involved in channel membership. So tomorrow, Mike Bernasconi, all about parametric projects, probably more than any of us need to know, but I'm going to pick his brain like crazy. Next Sunday, let me know. I'm going to try to have a video. Don't quote me on that. And thank you, Steve. Mike Bernasconi's website, envisioncreate.com. Go check it out. He's got some cool stuff over there. I now need to put a link in the description, and I'll do that as soon as we're done live. Also in the description, you will find a playlist of all of my two-sided machining projects. I believe there are 6 videos in that playlist, but there's a link in the description, along with links to Michael Mazalik's YouTube channel, Peter Pasuelo's YouTube channel, and Laney Shaughnessy's YouTube channel. A whole bunch of friends, good people, good resources, good information. Sargon is asking, is that a camera hanging in the background? Why, yes, it is. Yes, it is. That's one of my little non-CNC projects that I did. I made an overhead camera trolley so I can shoot video of the rotary in action. And here's hoping I'll put it to good use this week. So, not everything is put on YouTube. I don't do videos just for the sake of a video. It's really got to be something that folks want to see. That just wasn't it. Anyhow, that's enough for this week. Let's go ahead and close this down because I'm really going off the rails here. Thank you for spending part of your Sunday with me. I really appreciate it. You folks back in the Midwest, hunker down. Here's hoping this soon passes. Thank you again, Steve, for all that you do. I mean that sincerely. And thank you, folks. A couple of days ago, I went over 50,000 subscribers, which is a tremendous milestone for me. And it's all because of you. Thank you very much. You don't know what it means. It means more than I can ever tell you. I'm just shocked that anybody gives enough of a ding dong about anything I'm saying to want to come back. But for that many people, you guys rock. Thank you very much, and we'll see you next week. Have a great week.